implementing the same scheme for more complex equations like this, or even for something orders of magnitude more complex, is almost exactly the same. I mean, nothing really needs to change. Let me just show you by actually copying some of the code we had previously. Okay, let's just copy our arcade scheme on the previous lecture and paste it here. That's actually RK2 scheme, right? And well, the only thing we have to change is the right hand side. Okay, let's actually get rid of the n list, and we'll just choose n equal to a definite number. So let's actually choose a so we already let's choose a time. Let's say t equal to let's do 300 or so, and n is gonna be equal to t divided by dt. Okay, so here let's choose our dt to be something we know it has to be pretty small. So let's just put one more zero on here, so that it's 10,000th. Okay. And one thing different is that our initial solution cannot be, right, it cannot be a scalar anymore. It has to be a vector. Okay, and because we are always appending to the solution in the next row, so let's actually set this to be just a 1 0 to start with, which means my u is going to be 1 and my du dt v is going to be initially 0. Okay, I start from 1 at a stationary without any time derivatives. Okay, now when I'm computing my right hand side, instead of having the lambda times this, I'm going to call a function. Here I'm just going to call van der Pol function that's operated on u end. Same thing here. Okay,